brief introduction about me. I like to write. I write on third-party platforms like Medium, also AWS blogs, specifically the machine learning blog. I like to speak at reInvents and summits and also third-party conferences. I like to build and teach, so I build demos and workshops. Everything focused on machine learning. I like to sketch. I'm not very good at it, but I think I try to get some integrate some humor into technical content to make things a little more consumable, I guess. And one of the hard challenges of an introductory topic is uh, you have people from different backgrounds. You're all experts. You're all experts in different areas, but you're coming in with a different perspective. My journey to machine learning has been a little more boring and traditional. I started off in university and dabbled with open source libraries and frameworks, and eventually ended up using cloud for a lot of my production needs, whether it's training at scale or hosting models and so on. But today, these days, I primarily talk to people in two buckets. One is IT professionals, which I guess many of you are, who are already experts in cloud or have some expertise in cloud technologies and are trying to learn trying to learn machine learning themselves or support teams that do machine learning. And the other community I talk to is folks, data scientists and developers who have gathered some skills with machine learning libraries and toolkits, but look to scale their workloads in the cloud or host models in the cloud. So these are the two communities I primarily talk to. And having worn these different hats at different stages in my career, hopefully I can give you a perspective that's more relevant to you. So feel free to stop me and ask me questions or post questions on the chat room. And so the intersection of this Venn diagram is sort of my happy place, if you will. Okay, with that, here's a quick agenda. I'll briefly start off by what is machine learning. I guess some of you are experts or have deep familiarity with machine learning. Some of you are very new. So we'll still briefly introduce what it is, and then we'll talk about how you can get a head start with machine learning. Even if you're not an expert, I'll introduce two capabilities. One of them is Amazon SageMaker Autopilot. It's part of the Amazon SageMaker suite of services. I'll briefly introduce SageMaker if you're not familiar with it. I'll also talk about AutoGluon, not as popular as SageMaker because it's more of an open source library. It's popular in a different community, not so much in the cloud community. It's a library that AWS open sourced last year. You can run it on EC2 or your laptop or wherever you want. So one is a managed service, the other is an open source library. And maybe you don't want to train models, you just want to add intelligence to your applications. There are several AI services, and I'll talk about those too. I have plenty of demos, and I want to show demos to keep the talk interesting. And with that, let's get started. So a brief lay of the land, right? Before, it's really hard to interact with anything online where the data that is generated from your interaction isn't used to generate some sort of a recommendation or prediction today. From your smart home thermostat to recommendations from your shopping cart on what you want to buy, to banks trying to find anomalous transaction, every digital footprint is being used or passes through some model to generate some sort of a prediction or recommendation or forecast. And here's some examples of industry domains, but there are several others that are not here. And this is the world today. And all of this is powered by machine learning. So if you take a step back and take a look at what is machine learning, right? Sort of from the fundamentals. Say you're an organization and you sell products, and your customers buy products, and you want to recommend products to them. Historically, and people have been doing this for decades, is to come up with rules. You like product X, I'm pretty sure you might like product Y. Or you liked X and Y, I'm pretty sure you might like product Z. And you can enumerate these options, and a lot of companies do this, and a lot of businesses do this. These are rules, you come up with them. Or say you're NASA and you want to predict where a satellite is going to be this weekend at 6 p.m. There are different ways to make those predictions. You can go back to first principles and use equations written by geniuses like Einstein and Newton to, accurately forecast where the satellite's going to be. But there are a class of problems where you can't write handwritten rules like these, or you don't have first principles equations. And to give you an example, I have a sort of a quick demo here, and let me know if you can see my face on the screen. Okay. So do you see my screen right now? A nod would do from anyone.
Yes.
Okay.
We can see.
So all I'm doing here is taking my webcam feed and trying to determine if I'm happy, if I have a beard, mustache, smile, right? What do you know? Optimistic. I'm a 22-year-old happy male, so that's a good thing. So imagine doing this by either of those two different options. You can't enumerate all the rules to figure out what my expressions are. How do you go about writing these rules? And there aren't any first principles equations to do this. So in several such applications, you can actually learn these rules from data. And that's machine learning in a nutshell. So you learn these rules from data, and you can sort of describe this as, here's my description, which is you can use data to produce a program, often also called a model, and that program performs a task. It could be detecting faces or recommending products. So that's my nutshell overview of machine learning. And there are different ways to slice and dice different parts of machine learning. And I'll briefly give you an overview with some day-to-day examples so it's clearer. And again, if you're already familiar with machine learning, some of this may seem like things that you already know. But let's go over the most common way to slice machine learning. One is where you have input data and output data. Called supervised learning, where maybe you want to classify, further broken down to classification. You want to categorize something into red, blue, green, or true or false, or you want to forecast a specific value in the future, what the temperature or stock prices are going to be. Or in unsupervised learning, where you want to identify clusters in your data. So you just have data collected from some process. Maybe it's your metrics from telemetry from your some instruments, or maybe your cloud usage data, right? And this is just your data. There's no input. This is just input data. Maybe there are inherent clusters like these that you don't see right when you look at it, but you pass it through an algorithm and it'll tell you that, hey, there are clusters, and maybe one of these clusters mean that you have some anomaly in your system. So there's classification, regression, and clustering, and a few other categories as well. But broadly, these are the categories. You can slice them by. And an example of, is the Zoom window blocking the view? Okay. I don't know if it's just on my side. Okay. And a good example is an activity tracker, right? It'll tell you today how many steps you've taken today, how many stairs you've climbed. And this is actually a machine learning model running on your activity tracker. That's amazing how far we've come, because there's a model in there that's been trained on the accelerometer and gyroscope data to categorize into, walking, climbing stairs, sitting, sleeping. And ultimately it'll use the accelerometer data to, categorize your activities into these few steps. And these models run on watches today, right? Watches and phones. That's amazing. And forecasting is another example for regression, where you want to do financial forecasting, or maybe you want to forecast, resource consumption for next year, right? Here you're predicting sort of the finer continuous values rather than categorizing into buckets. So that's an example of regression. And clustering is a process of finding inherent patterns in your data. There are other unsupervised learning methods, but clustering is a popular one that people use. If you're car enthusiasts, you can buy one of these Bluetooth CAN bus devices and plug it into your car, and you can collect the RPM data and vehicle speed data. And if you actually plot the data, it looks something like this. Now, to the naked eye, you can see that there is some pattern here, right? And but what these patterns are, maybe you don't know. You can run a clustering algorithm on them, and you'll notice, these actually correspond to gears, so which means The red one is the first gear because you have low RPM and higher, low vehicle speed and high RPM, right? It's a simple example to illustrate the concept, but imagine a multidimensional data set. You have multiple columns and many rows, and you want to cluster them. So, and the clusters can maybe tell you that there are anomalous activity in your data, or there are different natural patterns in your data. So that's clustering. So there are different ways to slice and dice machine learning. Those are the popular ways. So it makes sense, right? You bring in your data, you provide it to an algorithm, and it'll generate a model that you can use to make, predictions or recommendations or forecasts. So that's all fine and great. So what are the challenges, right? The challenge is that there are many different machine learning algorithms that have been developed over decades. And each of these algorithms are very good for a specific type of problem. And part of what a data scientist or a machine learning developer would do is actually go find the right solution for the right problem, which involves a lot of experimentation and trying. And it's quite time consuming. This is assuming you have your data set ready to do machine learning. And the workflow itself can be complex, because before you actually do your machine learning, which is right about here, there are a lot of other steps that come before that. There's a collection of your data. There's cleaning, transforming your data, generating interesting features. For example, the accelerometer and gyroscope data I mentioned for activity trackers. Typically one of the steps you would use to actually train the model is to take windows of data, maybe half a second or 1 second, and then summarize them, and then use that as data set to train the model. You don't directly use the sensor data. So there are steps involved in actually before you actually train the model. And this process can be daunting for someone who's not spent their career doing this. And of course, there's deployment challenges as well. And the whole idea of automated machine learning is to actually automate as much as possible of this workflow. If you go back a few years in the past, like maybe 4 or 5 years in the past, there were automations, and they did just the training part. Over the years, the automated machine learning tools have started to expand and started to do most of the machine learning pipeline work. Now you have tools that are pretty good. You actually provide raw data, and it'll give you a highly accurate model by doing all the intermediate steps themselves. With that introduction to automated machine learning, I want to introduce two different services. One is Amazon SageMaker, and specifically a capability in SageMaker called Autopilot. For those of you who are new to SageMaker, SageMaker is a fully managed service for end-to-end machine learning. There are capabilities for actually authoring your code, an IDE for machine learning, data scientists and developers, but also fully managed training clusters, and labeling tools and hyperparameter optimization, whole suite of capabilities. And I'll briefly show them. But one of the newer additions to the list of capabilities is Autopilot. And as the name suggests, it's supposed to be on autopilot. You lift your hands off and let it do the work. And we'll see a demo of that. And another product that I'll also mention, this is for folks who like to hack a little more and run stuff on their own computers or laptops, test out. There's AutoGluon, also from AWS. We open sourced this last year, and you can run this wherever you want. And literally 3 lines of code, you can get state-of-the-art machine learning, state-of-the-art performance for a lot of problems. And I'll show how we've got competition-winning sort of benchmark results with AutoGluon. So I'll briefly talk about both these two capabilities to the rest of this talk. Okay, starting with Amazon SageMaker Autopilot. And SageMaker Autopilot is, as I mentioned, it's part of Amazon SageMaker. And at reInvent 2019, we announced SageMaker Studio. Over the years, SageMaker had added a lot of capabilities that developers and data scientists use to do machine learning. And these were independent capabilities that you would use together. And with Studio, what we attempted to do is put it under a single umbrella. So when you launch SageMaker Studio notebooks, you get this interface you see here on the right. And the advantage of this is it's the familiar Jupyter notebooks. If you're familiar with it, most data scientists, type Python codes in Jupyter notebooks, but we've integrated it more deeply into AWS services, which means you can pull up visualizations right within the notebook. You can pull up all the different experiments that you've run in the past. All of this is sort of deeply integrated into the rest of the AWS services, which means you don't have to jump back and forth between your development environment and the AWS console. So as a developer or data scientist, you just stay in one place. And there are other capabilities that I'm happy to talk about in a couple of other sessions, but we have experiment managers, debuggers, and Autopilot, and monitoring models that you host as endpoints and so on. Autopilot is interesting because you can actually do a lot without writing a single line of code. You can if you want to. We provide a programmatic way as well as a GUI way. And what you see here on the right is the GUI way, where all you have to do is specify sort of a name to an experiment, where your data set is, where it is located, and what you want to predict or forecast. It's typically in a comma separated value, a table or a spreadsheet that you can pull from a database of sorts. And as you specify this and you hit this nice orange button here, as soon as you click that, it's hands off. You just let it do the work. It'll go and train a bunch of different models, do different pre-processing steps, and it'll do all of this behind the scenes, spin up EC2 instances to train, manage all of that, shut them down when it's done, fully managed. Like, you don't have to do anything. And all you have to do is provide your data set, specify what it is that you want to classify or predict from your data set, and it'll do everything else. It'll also manage all the different experiments. And the interesting thing about Autopilot that's unique in my opinion is that everything it does is actually fully open and exposed. We call it a white box solution, because you'll find other automated machine learning solutions out there. Those are black boxes, which means they'll do similar things, but they don't tell you what it's doing. They'll give you like a model or host a model somewhere, and you don't know what it did. When you go through this step with Autopilot, it'll actually generate all the code that was used to arrive at the result. Now you can take the code and mess with it, learn with it, or run it on your own. And I'll show you this. It'll completely generate all the code that was used. So you can actually use it as a learning tool if you're new. So you can use the GUI way to kick off jobs, and you can take a look at the notebooks to learn what's happening behind the scenes. The second, before I jump into the demos, the second approach I mentioned is AutoGluon, a library that we open sourced last year. If you like to hack a little more, like to write a little bit of code, there's AutoGluon with literally 3 steps, 3 lines of code. Where is your data set? And it could be locally or it could be in Amazon S3. Where is your data set? Fit the second function, and then make predictions. Literally 3 lines of code. And behind the scenes, it's doing a whole bunch of things I'll talk about. And AutoGluon is a little more capable in some sense than SageMaker Autopilot as it is today. It'll do image classification, object detection, identifying objects in images, text classification, as well as tabular data prediction. It does a lot more different problems. Autopilot is today primarily focused on tabular data. So if you have tabular data with you want to make classifications of prediction forecasts, you can. With AutoGluon, you get a little more capability. That is not to say that this is always how it will be. Services evolve, products and features evolve over time, and we're bound to see more capabilities in both these 2 packages. A quick peek into what happens behind the scenes in AutoGluon. Again, everything I show here in this slide, you don't have to know, because when you call that fit function right here on top, this fit function, it does a whole bunch of things under the hood that you don't have to worry about. You just call this function, go get a cup of coffee or something. But behind the scenes, it does a bunch of things like looks at your data set, figures out, what is numeric data, what is text data, categorical data, if you have date or time information, and it'll discard things like, name ID or user ID that may not be useful for training a model. It'll also handle missing data, text data, all of this data pre-processing stuff that a data scientist would do. It'll handle it itself. And it'll also train a whole bunch of different models. If you don't know what these things are, that's absolutely fine. You don't need to know. It'll go train most popular ones like random forest and other decision tree based models, and also neural networks. And the interesting thing is it'll not just try all these things and tell you which is the best one. It also intelligently combines them. And the novelty, we put out a paper on this. The novelty behind the scenes is actually our team observed how expert data scientists do their work and codified all the best practices into a library. So whatever's in the AutoGluon library is actually stuff that expert data scientists do in practice, but it's just available to you in an automated manner today. Again, you don't have to worry about what's happening. You just need to call the fit function and you're golden. With that, let's take a look at an example. And the example is a pretty simple one for illustration. You have a data set here that's tabular, so that we can see both the different approaches. The tabular data set has, it's a bank marketing data set where you have some information about customers, and you have this prediction column Y. It's a binary classification problem, whether they will accept a bank offer or no, based on some historical information you have about them. Have they bought a loan from the bank in the past, or other demographic information about where they live and stuff like that. So this is, you might imagine why a bank would want this, so they can maximize who they cold call and make the offer. Rather than calling everyone, they may call just the prospective buyers. Hey, do you want this new loan or whatever, right? It's just an example of a binary classification. Now, the interesting thing here is that this is a very imbalanced data set, which means there are a lot more no's than there are yeses, which means, I think something like 95% of the data set is no and 5% is yes, something like that. And this is pretty common in real world, right? If you think about medical diagnostic data, it's all like that. Few cases are bad, and majority of the cases are healthy, right? So this is an example of such a notebook. And again, you don't have to specify that to Autopilot or AutoGluon. You just like, hey, here, take this and go do whatever you want with it and give me the best model, right? We'll see both these approaches. And with that, I want to jump into the console and SageMaker Studio and show you how things look. Now, if you're new to SageMaker, just like any other service on AWS, just look for it on the search, and you'll end up at the SageMaker console homepage, and you'll see a dashboard here. SageMaker, as I mentioned, is a fully managed service with a suite of capabilities. If you see on the left here, there's labeling, and labeling is important because you need input and output data to do supervised learning, either classification or regression. And in a lot of cases, you may not have the output data. You may have a bunch of images, but you don't know what's in the images. So you can actually get it labeled by people. And we support Amazon Mechanical Turk, to get it labeled by masses, or you can also, there are marketplace vendors you can leverage. This labeling, there's notebooks, as I mentioned, which is where you author your code. It's a fully managed notebook instance. By notebook, I'm specifically referring to Jupyter Notebooks, which is a common authoring location for data scientists. And we'll take a look at that. There are processing jobs to do pre-processing. There's training. The cool thing about training is that, again, it's fully managed. You can train on one EC2 instance or 100 or even 1,000, a couple of thousands. You can easily scale up. And the advantage is that when you submit a training job, it's not an instance that you have to manage. Your job trains there, and the instance is automatically shut down, and you actually get any information saying this is how many seconds you were billed, because that's the exact duration the training ran on the instance. And there are a couple of other capabilities like hosting models to do A/B testing and scaling, load balancing, stuff like that. And everything's fully managed here. But rather than focus on all the other things, I want to focus on Autopilot. And SageMaker Studio, as I mentioned, is place where we'll author. You can open up multiple users and create a studio, and this is what the studio interface looks like. It's if you're used to Jupyter notebooks, this should feel very familiar to you. If you're new to Jupyter notebooks, then this is where you can author your code, and data scientists typically put in Python scripts here and execute them. That's nice because it's a great prototyping environment for training models or exploring your data set. And this is sort of the place where a data scientist or a developer spend most of their time. But for SageMaker Autopilot, you actually don't have to write code. And if you see here on the left here, there's a Flask-like thing here. Ta-da! So if you click on this Flask-like thing, basically it opens up an experiment pane. And this experiment pane is, what you see here is a couple of experiments that I ran today and yesterday, or a few days ago. If you want to start a new Autopilot job, you click this Create Experiment button. And this is the same interface I showed you on the slide. So you can specify, I don't know, Tampa Bay example, right? Something like this. You can specify where your data set is, assuming you have your data set in Amazon S3. You want your data set to be in Amazon S3. And as I mentioned, again, this will only work with the tabular data today. So if you have your data in a database, you want to query it and dump it into S3 and then tell it where the data set is. You can specify what your output prediction value is. In this case, it's should a bank offer this to a specific customer. Let me open this data set up so you can actually take a look at what this looks like. So the tabular information. So I also have a local copy, but the data set is in Amazon S3 as well. So this is what the data set looks like. So there's demographic information about like age, job, and stuff like that. And at the very end, you will see the prediction value. So whether it's, you want to make the offer or not. So this is what the data set looks like. And that's the Y value here that I mentioned. This is what you want to predict, because Autopilot will go take a look at it. And after that, you can specify if you want to, dump the models that you train, jobs at some place, models, something like that, where you want to dump the trained models. And this is where you specify what kind of a machine learning problem it is. If you remember, I mentioned classification, regression, or multi-class classification, where you have more than one classes, like red, blue, green, instead of true or false. You don't actually have to specify what type of problem it is. Autopilot can automatically infer from your data set. So it'll take a look at the data set, the Y column, figure out if it's a continuous value or a categorical value with different classes, and figure it out. So I'm going to put it at auto. And after that, there's another option wherein you can actually have SageMaker Autopilot go run all the examples and give you the best model. Or, as I mentioned, you can have it generate the code that it'll use to run, but it won't actually run the training. It'll just generate the code for you. So you do this and say, create experiment right here in the bottom. What it'll do is now go kick off Autopilot experiment. It'll go through each of these stages. So it'll do analyzing data and then engineer features, which is take a look at how it wants to use all the different columns. Maybe it wants to remove certain columns. And then it will tune the models, because there are different models. It wants to find the best one. And finally, it will give you a model that you can then host directly from this interface here. Now,
out of curiosity, so at what point do we find out what this is costing us to do this?
So there are a couple of knobs that you can set. For example, by default, let me take a look at, show you the example of a model that I trained earlier, right? So here's a job that I trained earlier. And oh no, that's the one I just ran. So here's a job that I trained earlier. There are a couple of knobs that you would set. By default, it'll go and train so many different training jobs. I think there are, I don't know, like 100 or 150 or something like that. That's like, go find me the best of best everything, right? But you can get finer grained control if you actually submit the job by using either the APIs or the SageMaker SDK that we have. You can say, hey, just go run this on 4 instances. That way, you know that it's restricted to 4 instances, and you can say at any given time, just use 4 instances of this type, maybe, you know, M5, M4, something, and you can restrict it to that. And the advantage of managed instances here is that when it goes, trains and stops, you're only billed for the duration on that M5 instances that the training ran. So if it ran for 10 minutes, you're basically billed for 10 minutes on those instances. So if you want finer grained control on how much, the rest of it, the main fee is associated in the training instances, right? By default, when you use the UI, you don't have that level of fine-grained control. But you can, when you use the API, you just specify, you know, 4 instances.
Yeah.
You can also say, yeah.
I would presume after so many runs of this, you begin, especially if you use the large number of models, begin to come out with a pattern that says, hey, these 3 or 4 seem to give me the best results, the more accurate results, right? So like you said, tuning the knobs, you just kind of select the 3 or 4 that tend to come up with a better result.
So good point. And the reason for that is, as I mentioned earlier, if you recall, you don't actually have to run the entire Autopilot training job. You can actually have it generate candidate notebooks with all the code. So you see these 2 buttons here. If you actually choose to do this, you can generate this notebook. This notebook has all the stuff that it's going to run anyway. When you create a new training job, Autopilot job, there is an option here below that says, do you want to run the complete experiment? You can say no, don't run the experiment, just generate the code for me. And if you actually do that, you will get these 2 candidate notebooks. And in this notebook, you have all the code that it would have run anyway if you asked it to run. And you can take a look at this and actually adjust a lot of knobs. If you scroll a little lower, this is the data pre-processing. Let me show you the actual, this is the right one. So this is the candidate. It's fully commented. It'll look at all the generated candidates. So if you scroll down here, you can see all the different candidates. Okay, here. So you'll see here that candidate 1 is data pre-processing 1 with the XGBoost algorithm. And it explains, here I'm using robust imputer because it's a way to, you know, replace missing values, and I use blah, blah, blah. Then step 2, I'm going to use a different type of data pre-processing, and I'm going to use a different algorithm called linear learning. And you can see all these different options here. So what you can do is actually generate this notebook. And if you feel like you have a high level understanding of what you want to do, then you can go delete all of these cells, or just choose the one that you want to run. You feel like, hey, I just want to run this one cell. Just, feel free to go ahead and run this cell. And here you will see that in a given cell, you have, this is my instance type, and this is the instance count, right? Maybe I want to run this on a T3 instance. Maybe it'll take a little longer, but that's okay. So you have that fine-grained control when you actually do it yourself. That's why we call it a white box solution, because it's autopilot, but you can become the pilot if you want to, sort of. So you have control then. So you actually know how much you'll end up spending. But if you want the complete hands-off experience, then it's gonna do the best thing it can. And here you'll see that after training these 100 or so models, it gives me here the best tuning job. One thing I want to mention is in addition to training all these different options, it also tunes the parameters of these models. And it does that using a process called hyperparameter optimization. So whole topic on itself, but there are knobs that you set before training, such as learning rate and a few things that usually a data scientist would set. But in this case, it's actually going to go find those. So if there are 10 approaches, then each of those 10 approaches, will have different hyperparameter tuning jobs itself, which is why there is a wide combination of these things. But you can take control and restrict your search space, which is a pretty common practice. People restrict their search space so they at least know what they're starting with, and it's not like a blind spray and pray sort of a strategy.
So I'm
But if you do,
assuming then the studio is not going to give us a price from this interface. It's
not in
going
this interface, no. The control you have in this interface is more of what resources are you consuming, or what type of resources are you consuming. Do you want to run this on a GPU instance or a CPU instance or a lower? You have control over that. You also have control over how long the job will run. You can put up a wall time. Don't run it for more than 10 minutes, something like. You have control over that. But you can also if you use the API, also see the duration of execution. For example, you could probably even see it in this interface. You'll see how long it ran, but you like it'll tell you billable seconds. Oh, it runs for 452 seconds, right? You can see that, but not the actual price. No. And yeah, once you train, you get this list here, and you'll see here, it has a 92% accuracy for this particular problem, and you can actually deploy the model right from here. You can say right click deploy, and you can again specify the type of instance here, and maybe I'll just test or something like that. And the couple of advanced settings here, if you want to monitor a model when it's deployed, which is a common practice, because you'll deploy a model today, and 6 months later, is the model still relevant? Because you had new customers, you have new data sets, and maybe that model is not relevant anymore. And there's a way to automatically monitor and check. There's a whole service called SageMaker model monitoring, whole capability. So you can switch on the data capture option to do that. But this is called one-click deploy, because with just this, I can deploy a model and I can enable monitoring if I want. And again, there's a button here. If you click on this, it'll start creating this endpoint. So it's actually, you can take a look at this endpoint that's being created. So this model will be hosted as a sort of a microservice that you can invoke to get. A bank can then have their mobile app, send a request and get back results saying yes, submit the offer, offer the client something or don't offer, right? This is the big, I guess, advantage of Studio is that a data scientist or a developer shouldn't have to leave this interface, to go to 5 different places. A couple of other capabilities that I didn't show is like visualization. You can actually compare a couple of graphs and stuff like that. More useful in if you're training like deep learning models and stuff like that. But there are a lot of capabilities built into this that makes life easy. So that's sort of a quick overview of Autopilot. You can do a lot without writing code, as I mentioned. And I do want to show the alternative, which is AutoGluon. It's an open source library, as I mentioned. You can do pretty much the same thing, but in this case, rather than run it on a SageMaker managed training, I will run it right here. So one of the advantages of Studio, which is something I think new to many of you, is you can actually switch backends pretty seamlessly in this interface. Unlike what you may have used or what you may be familiar with, this is not an EC2 instance that is fixed. The backend is actually pretty fluid and flexible. So what you see here is an interface that can easily switch backends. Now, right now, you can, if you're just training on Autopilot, then you can write the code in a T2 instance or something like that. But if you actually want to train here, you want to build models on this interface, you want a beefier instance, you can go back and switch an instance to something much more beefy. Oh, give me 96 vCPUs or something like that, which is what I've done here. I've switched the backend, and you can keep switching these backends pretty seamlessly. That way, if you want to train something on a heavy model, you switch it to a heavy beefy instance. If you want to just explore data, you switch it back to something mild, right? And you can do this like pretty seamlessly here. This is what I've done, because in AutoGluon, I'm going to train it right on this instance. So I switched it to a beefy instance. You see here, like a 32 vCP, 120. I probably don't need that much, but maybe you do depending on the problem. And the advantage of AutoGlow here is, if I collapse all these cells here, there's literally 3 lines of code that you need to get state-of-the-art result. One is you want to load the data set, and with AutoGlow I'm loading this from Amazon S3, but I may very well have it locally, loaded from locally. And then all I have to do is literally call this function called fit function, where I provide the data set and what the label is, and that's it. It'll go train all those 8 different models I mentioned. Let's go actually run this. It'll go train all the 8 different models behind the scenes, and this is what the data set looks like. And I'll just kickstart the training. It takes 20 minutes or so. I won't make you stare at the screen, but if you see here, it'll start fitting model. So model 1 fitting this. It'll keep fitting all these different models, and it's training right here on this specific notebook. So there isn't like a separate managed instance that's being used behind the scenes. And so it trained the first model. Now it's training the second model here. So this is model 1, and this is model 2, and it'll keep going at this. Again, you can go get a cup of coffee or something like that and come back, and I'll show you what the final trained output looks like. So once it's trained, you see all these different models, how much time it took. And in this case, the time is not very relevant to how much you're billed, because you're billed by how long you're using this instance type here with this particular CPU type behind the scenes. And once it's trained, you can actually now take a look at a leaderboard. Oh, here are all the models it trained. Here's all the accuracy. And the fun thing is actually, it's not just, it's also combining different models to get you the best models. Again, you don't have to know what it's doing. You do that, and finally you can make predictions, and you get good score here of 90% or so. In the AutoGlow case, I ran everything on my notebook, and literally it was like 3 lines of code. And another example that I want to show is some of you may be familiar with Kaggle. If you're not, it's sort of like this data science competition platform, like Top Coder and stuff like that, where for prize money you can take their data set, train models, and submit. And if you win, you can win money. This particular competition had $10,000 prize money, but I think there have been competitions with like $1 million prize money. And what our team did is actually they took AutoGlow and just ran it on a bunch of these competitions, and we actually got like top results in a whole bunch of these competitions. Top 1% results, not the absolute winning entry, because then you have to do more work. But what you see here on the left is all the code that we needed. Data scientists actually spend months together fine-tuning every aspect of their model to actually get these top scores. Here we have to throw, this is where my data set is, and this is the fit function. And once that's it, I'm basically 2 steps. And we actually end up getting, I have the notebook here. We actually end up getting top 1% result. And I actually submitted this to the competition. Although the competition is closed now, the competition itself is about classifying product category. It ran a few years ago, but they let you submit results just for fun, right? If you want to compete with yourself. So when I submitted, I got this. They compare it with their private data set, how your model performs. I got a private score of 0.41. This is not accuracy, it's another metric. You can actually go to the leaderboard and see what 0.41 nets you. So 0.41 will kind of, I think, 0.40 on the public board, 0.407. So you can actually go to the leaderboard and see 0.407 will probably put you somewhere around 31, 32 position. Now 31 is not 1, but take a look at how many teams were there. So there were 31 divided by that's like, I don't know, you're in the top 1%, right? So there you go. You're in the top 1% of the submissions, and all you have to do is like write 3 lines of code. You can then fine tune and get better results. And we actually have code for, I don't know, 5 or 6 different competitions that we submitted, and it's on the AutoGlow webpage if you want to check it out. This is great for a lot of developers who are not machine learning people. They can get a great head start. And our team actually basically took best practices of the data scientists and put it into a library. That's what they did. So that's sort of AutoGlow on summary. And there are a couple of resources on the left if you really want to dig deep into what's happening behind the scenes. If you're curious, here's a blog post that I wrote on AWS open source blog on how AutoGlow works. There's also more information on Autopilot. So I spoke a lot about AutoGlow and Autopilot. I want to set some context into where this fits into the AWS portfolio. AWS has large machine learning portfolio, and the way we think about it is broadly split into 3 categories. There's stuff that you're all familiar with in the set, that there's infrastructure services. You can get EC2 instances, you can get container repositories. There are also deep learning containers that AWS offers. There's also CPUs and GPUs and whatnot. So there's all these building block stuff. These are good for people who want that flexibility, they're building their own capabilities and services like that. But a lot of teams and companies want to use a little more of a managed experience, and that's where SageMaker comes in. They don't want to manage EC2 instances. They don't want to manage Spot instances and stuff like that. SageMaker has built-in support for Spot. So with just a flag, it'll take advantage of Spot instances. They don't want to host models and figure out auto balance, load balancing and auto scaling and stuff like that. So that's all part of SageMaker suite of capabilities. And we can talk about that for a long time because there's so many different capabilities there. And the third thing, which is really popular, and some of you may be familiar with this, are these ML powered services. I don't want to call this machine learning because it may use machine learning behind the scenes, but as a user, it's an API call for you. You can use you can make an API call to get a whole range of capabilities from image recognition to language translations to text to speech and understanding natural language demand forecasting and stuff like that. This is great for developers wanting to integrate. Let's say your core competence is building an application, but you don't want to spend time. You want to add an accessibility feature, but you don't want to build a machine learning model to do text to speech, right? That's not where you want to spend your time because you're building a different product. And you can use text to speech capability so that you can which is called Poly, AWS Poly, Amazon Poly, and you can use that to actually add that capability. So there are a lot of these services that let you make smart applications without actually having to do any training or machine learning. And maybe you find that you want to personalize it a little more, and then you can go back and actually train your own models. And it's if you use this, it's super easy to use. You can test drive it on the console, or you can choose your favorite programming language with 3 lines of code. You can say, I want to use recognition, and here's my face. Go get me a whole bunch of information about my face, which is what I did in the very first demo, which I briefly showed you at the beginning. And if you actually look at the number of code required, it's actually just this 1 line of code here. So I want to say recognition.detect face. So I pass my face information here. From the rest of the script is all about getting my webcam feed. And once I get my webcam feed, I just pass it to this recognition client, and I say detect faces. When you get a response, it actually gives you, I don't know, like tens or even hundreds of different attributes, like where is your eyes and where's your nose, and do you look happy or sad, and beard and whatnot. There's this whole bunch of information that you get. You can then filter through that and decide that you want to, you only want certain specific information. You don't want all the other information. And this is the, the result. Like I wouldn't build rules for this. I don't have equations for this, and I probably don't want to train my own model for this because I don't have enough data. But I can, apparently I was confused there for a moment. And so that's AI services for you, and that's great if you if you want to add some AI capabilities to your application without actually training your own model. So I don't know if I went over, but I'll pause here. And I just want to say, thanks for listening. And if you have questions now, I'll be happy to answer. But also maybe tomorrow, day after, a week from now, I can be reached on Twitter, LinkedIn. I also blog on Medium. And yeah, if you like this or have feedback, you feel free to share this with me now or publicly or in private. Up to you. So yeah, we can have a discussion now. I leave it up to you, Jeff and Sam, how you want to proceed.
Yeah, we'll open it up to questions, and maybe I'll start with the first one. So, in your example, you had a data set that you imported for analysis. Give us a feel for how large of a data set, is typically required to get meaningful results. Are we talking hundreds, thousands, millions of rows of data? Give us a feel for, what's required to get us a pretty accurate model.
I want to say like more, you'll hear this a lot in machine learning, which is like, it depends on the problem. And that's true because it depends, first of all, what domain it's in, whether you're doing, classification from tabular data or, forecasting from tabular data, or whether you're building, image recognition or, image segmentation, or you're building a speech analysis model. Each of these applications will have different constraints, different requirements. For tabular data, usually, I don't know, 100, we have examples. If it's a simple enough problem where the classification is not that confusing, a couple of hundred, data points would be sufficient. The problem is easily solvable. A lot of the Kaggle data science competitions, for example, have really, really hard problems wherein it's very difficult to classify because they're not easily, they're not separable in that high dimensional space, they say. It's not easy to, in those cases, you need two things. You need sometimes more data, and you need more sophisticated models. The sophisticated model part is taken care of for you because when either of these two services, they try a different bunch of options and they'll find something for you. But if you can't push your accuracy beyond a certain limit after running Autopilot or AutoGluon, at that point, you know that, okay, your other option is to now go get more data. So work with what you have is what I would say. Try to push the limits of what you can achieve with what you have. And when you don't, is then, okay, I need more data, and you go get more data. And usually the trap is, it's not about more data, it's more diversity in data. If you get the same type of data, think about this, like you're a self-driving car, and if you're driving on a long highway collecting data, and you train a model, it's not good, you want to get more data, you don't want to drive on the same highway
Right.
10, 20 more miles, right? You want to drive in the night, you want to drive in the morning, you want to drive when it's snowing, right? You want diversity and quality if you want to improve robustness of your model. So that's sort of the short answer. Work with what you have, and then if you feel like you're not progressing beyond an accuracy, if you're hitting a 70% accuracy wall on your test set and you're not improving, then that's a good time to collect more data. And another thing I will mention though is in other domains like speech and image kind of domains, you can actually get away with less data because of pre-trained models. Like research organizations and large organizations have already trained these models on large databases of images and speech and stuff like that, or text and stuff like that. You don't have to actually start from scratch. You actually use those and fine tune on your data. So if you're trying to identify vehicles on your street, you don't start from scratch. You actually get a model that identifies vehicles and then fine tune it on your vehicles by collecting hundreds or thousands of samples. And again, you try to maximize accuracy, only then go get more data if you feel like
Right.
you're not improving beyond what you want.
Okay.
Did that answer your question?
Yeah, absolutely.
It's a sort of a nuanced topic. a common question though, for sure.
Any other questions from any of the attendees?
Fire away, anyone. You can write it if you'd rather not talk, and we can read it for you.
Yeah. Oh no, I didn't. I'm not familiar with Zoom. Okay, there it is. Okay. Isn't it?
So I have one question. So
Yeah.
this is
Go ahead.
Darshil, and I work for one of the Tampa company, Nielsen. So I have seen in the SageMaker console that there was a Git option as well. So
Right.
when you run the that autopilot capability, like if we generate like a bunch of training models, so how can we integrate those models or their code with the existing Git repositories and everything? That is my question, is like how the Git is integrated.
Okay, so I imagine you're thinking on the lines of sort of CI/CD pipelines, right? How
Yeah.
do you order? So there are a couple of ways Git integrates with SageMaker. Let's see. So one is you can actually, if your code is in Git, not your models. I mean, there are some basic integrations here. There's a whole Git menu here. You can clone your repository and train a model here. Train here, and the models you can push to Amazon S3. But separately, there's a service called AWS Step Functions. Maybe you're familiar with that. And there's also other CI/CD tools. But Step Functions is great because we have a data science integration there where we have some examples and I can share where you can provide an end-to-end pipeline wherein you will actually you arrive there once you're not doing the exploratory phase. So here we are doing the exploratory phase. Say you've done with the exploratory phase and you're at a stage wherein new data comes in and you want to automatically kick off training, maybe an autopilot job, and the model comes out at the other end. You want to automatically host the model with a SageMaker endpoint, and then serve that sort of pipeline you can orchestrate from some tools like Step Function. There, you're not in this exploratory mode. You're more in a productionizing mode, wherein you can invoke these training. You can invoke an autopilot job. I showed you can generate these notebooks, right? These notebooks. So you can actually invoke the code in this notebook either as a Python script or something like that from some CI/CD. There are many options for that, right? There's AWS Step Functions. There's also, I think we have like Code Pipeline and a few other tools. There's also third-party stuff. There's like MLflow, Airflow, Kubeflow pipelines. There are so many different options, but the way to do that is to actually use the API way to do it, like the SDK way to do it, not the UI, right? You take this code in this notebook, you push it to Git or something like that, and in your pipeline, have it invoke this, and as a next step, host it, and as a next step, do something else. You can make it part of it. Data science, SDK, Step Functions. I'm pretty bad at typing fast. So there's this capability called AWS Step Functions for Data Science SDK. So the cool thing is you can, as I mentioned, you can. I think we have some sample notebooks, and I should mention there's like 300 different sample Jupyter notebooks in this Amazon SageMaker example. So I don't know. No matter what you're trying to do, there's probably some example here. There's an entire thing for Step Functions where you can, feel free to check it out. And there's some blog posts we've done on that topic as well. You can build a pipeline, and I thought there was a nice image somewhere, like showing all the different steps in the Step Function. Yeah, something like this. So you can create all this. Here, start, extract, transform. Each of these are steps. You build this DAG graph, direct acyclic graph. So each of these will invoke. So when you model training will invoke, autopilot. Here you invoke autopilot. You save to S3 or something like that. You then host it with SageMaker, and if model is greater than 90%, do something with it, or otherwise do something else with it. So you can build pipelines like this, push it to Git and stuff like that. Check out Step Functions. That's probably something that you might find interesting.
Okay, cool. Thank you. Thank you for your answer.
And I think if anyone knows any local companies that are using machine learning on AWS, it'd always be great to have a case study. I know a lot of us are here learning about it the first time, but if anyone knows anyone at a local company that at some point would love to, obviously not give away any intellectual property, but talk about how they are using machine learning to benefit their business, I think that would be great also. Any
I'll
other
share
questions?
slides with Jeff and Sam for some of the folks who asked, and they can host it on Meetup or on your page or wherever. Yeah, I'm happy to share slides with them.
Yeah, we can push that out, whatever way is easiest to receive. Or we can collect that and get that out to you guys, and we can set links, whichever way is easiest. It's all on your pages as well, isn't it? So.
Okay, I don't see any questions.
I have a
here.
question.
Yeah, go ahead.
My name is Arman. I'm brand new to the group, dialing in from Reston, Virginia. I got a question. What are the requirements, the prerequisite to get started with SageMaker? Do you go and create an account, and what type of account, and how does it work? I didn't see that slide.
Yeah, no, I didn't cover that. I sort of directly jumped into what is machine learning and how to use Autopilot. But there are you can start off with a free tier account. I think if you go to the home page, you do get started with SageMaker, and it'll prompt you to okay, I am logging in, but otherwise it'll prompt you to create a free tier account, and you get a bunch of things. I don't know if you listed on the product page. You get there's under price, there's this what is covered in a free tier section somewhere. Getting started maybe. They tell you what exactly is covered in the free tier. Here. Yeah, you get 50 hours of training with you what do you get? You get 250 hours of T2 T3 medium notebook usage. So notebook usage, basically what I was typing code there for. 50 hours of training with M instances. You should be able to easily run an Autopilot job and not pay for it, and hosting models and stuff like that. That's pretty good. The other way is to actually we do these workshops every now and then. We also give out, I don't know, usually like $100 credits and stuff like that. We used to do a lot more of these when we were actually able to host events in person. But even now we do a lot of these online events. One of them is called, I'll share a link maybe if I can. We did one last month, and whenever you attend these events, we actually also give out credits in many cases. But free tier is a great place to get started.
Free tier. Okay, great. Thank you so much.
I should always include this in my presentation.
The next one, next presentation.
Yeah, no, it's how to get started is yeah.
Yeah. All right. Thank you. Appreciate it.
All right. Any other questions from anybody?
Hi, this is John Griffin.
Hey, John.
Yeah, I have a question. Let's suppose this is of interest and I'm a zero. So I'm guessing that just starting out with SageMaker and pushing buttons is probably a way to get results that I don't understand. So do you have any training suggestions, or like Coursera stuff or stuff in AWS?
I think we recently ML, what is it called? I forget the link. ML training or AWS training or something like that. AWS ML. So we recently made like a lot of our trainings free, like the actual training videos and all of it was free. I forget what the link is, but there's a whole bunch of, some of this is geared towards you trying to get the ML certificate, but I mean there's also good instructional trainings that actually were used internally that they actually made it external. So there's a bunch of training. I don't have a link handy, but maybe I can follow up and share it with. I can put in the slides actually. Yeah, I know there's a couple of links. We have free training. I think just like last week or something like that. We just opened up all the internal trainings to external. So that's more. If you want to get started with concepts and what is machine learning, it's a little more time investment, right? As in, you want to do it the right way, sort of an approach. I can add the link to the slides when I shared, which will get shared with you. Outside of that, there's two things, right? There's you can go deep into learning how machine learning works, or you can get productive by hacking and
Okay.
training models. Both are valid approaches. Right? I in fact not I just bought this book recently called what is it, Deep Learning for Coders. I'm just started reading it. So the approach this author is taking is it's for coders, right? Don't worry if you don't understand machine learning theory. I don't care. Just we'll teach you by writing lines of code. So there are different schools. I guess you could do the deep theory version, or you can do the hack with code and eventually learn the theory version. And for the courses, AWS courses, I will add a link to the slides. It'll eventually reach you through the organizers.
Thanks a lot. It was a good talk too.
I think I saw a question here. Someone asked, "Is Python the only supported programming language?" Actually, you can use R, you can use Julia. There are a couple of different languages I think that are supported. There's also the concept of not specifically with Autopilot, but there's this concept of bring your own container if you're using SageMaker. We have customers who have maybe some esoteric language or maybe existing languages, but some very proprietary stuff. They build their own containers, and you can have SageMaker. Use SageMaker as an orchestration service, managed orchestration service. So let's say here's my container. Please go train this on so many instance types, or please go host this container as a model, and SageMaker will still do that. So that's sort of the other extreme of using SageMaker, wherein you just bring your own container and you can put Java in it. You can put whatever you want in the container, and SageMaker will either train or post a model and stuff like that. That's but as far as the notebook experience is concerned, we have a couple of examples of using R. If you're an R user, which is common in very statistics and data science sort of organizations, there's also support for newer Julia, and you will find these examples for sure on the AWS samples GitHub repository. So in the AWS samples GitHub repository, you'll find, for example, here's R examples. If you're an R user, we have Spark integration. If you do your ETL, like extract, transform, load, all your data pre-processing on Spark, then SageMaker has Spark integration. So there are a couple of other supported languages as well. So, but Python is the language of the data science, so to say. most developers prefer Python in this community, at least.
Yeah. Thank you. This is Mina. I asked Mina Yusuf from Clearwater, Florida, and I asked that question. And just to add to this as a clarification, so you can deploy that model right after to, for example, to a Golang Lambda or any other language to run that model.
So model hosting is an interesting topic. There are a couple of different options. The most easiest way to do is to use SageMaker model hosting. And the advantage of that is, you'll see here that there are, on the left here, there's a whole section for inference. The advantage is you get a lot of, so this is the model I just posted while I was doing the demo. The advantage is that you get a lot of things out of the box that you want from a model. You get auto scaling, you can do A/B testing. All of this is like out of the box. You can view, monitor usage. There's another capability called model monitoring, as I mentioned, wherein you can collect when customers ping your, or internal or external customers get requests from your model, you can collect that data and dump it into S3 and analyze it. So there's a lot of these out of the box capabilities that you get, and which is why some customers actually use SageMaker only for model hosting. They actually train on their own laptops or wherever, desktop. So and they use SageMaker model hosting because it's convenient. That being said, you will get the model trained from this as a, as a tar file that's in Amazon S3. Go take that model and deploy wherever you want. Like, you want to host it in a Lambda, just make sure that you have the right, dependencies, and the model fits in that Lambda function, because if you have a large model, it won't. As long as, check those boxes, yeah, just, host it wherever you want. Some customers even host it on their own EC2 instances because that's what they do. But this is the simplest and easiest way, because literally I hosted this model by right clicking on this this right? I want to deploy this, I just do this deploy model and I host a model. So it's that simple. Yeah, but it's flexible. It's a modular service, which means use the capabilities that you need and only use the ones that you want to use.
Great, thank you.
Hey, I have a question, please.
Sure.
So this is Bokle from Tampa. So I think it's my first time to attend the event. So I have a question about I want to know the difference between, because I have been playing with Deep Racer.
Deep Racer.
Yes, so in Deep Racer, all you have to do is to write your reward function, right?
Yeah,
so I want to know the difference here between the reward function and the models. It's kind of a little bit confused to me.
Okay, so I only have a sort of a brief exposure to Deep Racer. I'm not an expert on it by any means, but the idea with Deep Racer is for the rest of you who may not be familiar, we have this, this small car vehicle that we have tracks, and you can compete with each other by, tweaking tweaking the reward function. I'll come to what that is. So you can compete, right? It's a fun project and a way to get into machine learning. The difference with Deep Racer and some of the things I showed here is Deep Racer is really trying to abstract away as much as machine learning as possible, so that you don't have to worry about, a lot of it's complex. Like Deep Racer uses, reinforcement learning. It's an advanced topic. It's complex. It's very difficult to learn. You actually start with these things I showed, classification, regression. Reinforcement learning is pretty complex. So in order to simplify that, of all the things that are in a reinforcement learning framework, including model training and all that, they just expose a small part of the thing that you can actually tune, which is the reward function, for how to stay on track and how to navigate obstacles. So they're actually hiding all the other stuff from you, just so that it's more approachable and easier, and it's more fun. You compete without. But behind the scenes, it's actually being used to train the model. You're actually training a model behind the scenes. But it's not like a classification regression. It's a reinforcement learning model, which it tends to be a little more complex. But basically there is a model behind the scenes. It's just that it's not. They try to make it more approachable to a lot of developers.
Okay, and the example you show about for the face recognition, so you use AutoML for that?
No, so that's you can, but I used the recognition AI service, which I was showing. It's like a couple of lines of code here. So it's just one line of code actually. A recognition client. So I invoke this recognition client and I detect faces. My responses has a whole bunch of things, and I just filter out the 4 things I show. You can do this yourself, which means you have to collect data. You have to collect data, then you have to, you need enough data with all those characteristics. If you want to detect like beard, no beard, or smile, then you need to collect, I don't know, a couple of hundreds of maybe photos with smiles and frowns and stuff like that. And you can use AutoGluon, because AutoGluon, you can't use Autopilot, but you can use AutoGluon. AutoGluon has image classification. If you're on the box around my face, then you have to do an object detection model. But if you just want a tag, like am I smiling, am I frowning, am I do I have a beard, that sort of thing, you can use auto glue on. It's the same, it's equally easy to do as long as you have the data set. With auto glue on, there you go. So auto glue on supports image classification, and also object detection. And as I mentioned, like the fun thing is it's just 3 lines of code. You provide your data set and you just do a task.fit. You'll see you provide your data set. In this case, data set would be your training data set. You place it locally in a directory with the classes, smiling, frowning, stuff like that. And this uses deep learning behind the scenes. Again, you don't have to worry about what it's doing, but it'll actually train and give you results. But you need data sets. Whereas if you use recognition, you don't need to know machine learning even. Just a function call away.
Okay, thank you.
Yeah, this would be a fun exercise to try actually. I mean, someone asked how many images do you need, right? How much data? You can get good results because there are some of these pre-trained models that we ship have been trained on. There's a list somewhere of so we don't train from scratch. So we'll use a model that exists and take your data set and train. So some of these models are already capable of recognizing objects and faces. So you can, what we call, fine tune it. So go collect, 100 or 50, different expressions, put it in a directory, call autoglue on, and hopefully you'll have a good model actually. If it's not as accurate, then you can always dump a little more information. And it could be a good, fun project. I have friends who did this. One of my friend just did the same thing with cat detection in his garage or something like that. So it won't be hard. It's worth a quick project, weekend project.
Thank you.
Anyone else got any questions?
Another thing I should mention is if there's stuff that you heard from today's talk or other topics that you think we could explore further, I think let the organizers know. We can plan something if it's interesting. Maybe a deeper dive on, I don't know, some aspect of SageMaker, some aspect of machine learning. Maybe
Yeah, because I think we were talking about workshops and things that you've done in the past.
Yeah.
I think you touched on that previously. It's definitely
Right.
something you're keen to do again, I guess.
We can, I propose, I was talking to talking to Sam about this. If you think you want to spend time, typing on the keyboard, we can set up like a 2-hour workshop thing. Like less instruction, more hacking. So, I'll provide notebooks and stuff like that. Maybe we can arrange for credits and you can hack on your keyboard, learn something while you're in the call for half a day or a couple of hours. It's an option. I see one enthusiastic yes. So that works for me. So, but I feel like, yeah, just let the organizers know we can plan something. I mean, we're flexible. I think we want to engage with you, and yeah,
I think that could be something that's really different and really engaging. You'd have to bring your own beer. Unfortunately, guys, I'm not shipping it to you, but I reckon that could be really fun. We'll put a poll out or something and organize it as a separate event. That's a brilliant idea.
Yeah, and I can provision two ways to do this. I can either provision like burner accounts for you, just it's a sandbox, or we can figure out credits. So bring your own AWS accounts and apply credits. We can do either. It's flexible. We can do it in plenty of different ways. I think the harder thing for me would be like, what topic do you want to learn, right? Like what specific service do you want to learn? And if there are ideas, just share it either in the chat here or with organizers, and we'll figure it out.
Shashank, I have one question.
Yeah, go ahead.
So, for example, let's take one example where we, we are implementing the regression, okay? And if we use SageMaker, generally, so I know by your example that there will be a different models that will run probably 100 model, for example, and will give me the best R square or whatever accuracy
Yeah,
measure that we have provided. So
correct.
for example, uh, it will do the transformations like log linear or linear log or log log. You know what I'm going? Uh,
For the features,
yeah,
transformation
for
for the,
the features.
yeah,
Yeah.
yeah. Actually, if you take a look at some of the generated notebooks,
Okay.
if you take a look at this, you'll dig through to see specifically what it's doing, but they'll mention what it's like. Some of these will do feature transformations, some of them will do imputing, but it'll figure out what it thinks is the right thing to do by looking at your data set. So,
Okay.
for example, if your data set has a feature that goes from 0.01 to 10 million, then then it'll probably take a log transform. But if you have a data set wherein it's a more uniformly distributed, they probably won't do the transformation, right? So there are some clever things that it'll do behind the scenes.
Okay.
And this is where, data scientists spend time on, and these are things that it'll automate. In this data set, maybe it didn't think it needed to do anything like that. So it didn't do anything like that. Maybe. I haven't looked at it thoroughly. But it'll do it behind the scenes for you. So that you don't have to ultimately, like, it'll give you the best model. It'll
That
try to
may,
yeah.
okay, thank you for your answer. I think in that case, it may be a truly autopilot.
Yeah, I think the field is still evolving, right? I mean, 4 years ago, if you said AutoML is like, they didn't do much, but they're getting really good these days. Yeah.
Correct. Thank you.
So I've got a quick question for everyone who's still on in the chat window. One of the things I always debate is, most of us have pretty busy daytime jobs, but would people like us to keep doing this in the evenings after work at 6 o'clock, or are people open to considering sessions during the day? When we meet in person, it's always easy to say after work is what makes sense, but I know people have home time with families. So if you have a preference, I think Sam and I are going to be working on a questionnaire about that. But if anyone has a preference during the day or after work, if you want to just put that in the chat window, that'd be great as we work to schedule these. Not everyone type at once.
Yeah, we know you've got day jobs and it's not easy for you to, block out times in your diaries and projects and deadlines that you guys have got to hit. And the evenings does sound like the logical option for most, and it may just be the evenings we stick to, but maybe we can mix it up as well in midday or whatever it is. We can always test it out.
Yeah, it looks like a lot of either one or after work. So that kind of tells us we're on the right path. So
we could do a morning one with orange juices and croissants, cool things like that. Whatever works.
All right.
I'll go with whatever anyone wants.
Cool.
Yeah.
All right.
I really like the idea of almost like a live hackathon or almost like a live workshop. I definitely think that's got some legs. Something that we could organize. Maybe give it a couple of months so we can probably get that streamlined and post it something different. Call it a workshop, a live workshop, and I'm sure we'll be able to host it just very similar to this and make a go of it. If that's something you're willing to do, Shashank, that'd be brilliant.
Yeah, no, I'm super interested, and Jeff, maybe there are Jeff and Sam, there are neighboring user groups, or I mean, it's online, right? If you have. If you want to join forces, right, a neighboring user group or other meetups, then you could co-promote, and that way you get a little more critical mass.
Yeah, I think the great thing about Amazon is they do have a Slack group for all of us meetup organizers, and so it was pretty easy for me to reach out to the other organizers and combine for that event. So that would be great.
Yeah, all your lovely faces have been recorded as well throughout this process. So, but we do this for anyone that couldn't make it, that had signed up, and also people that are here that just want to re-listen to Shashank's lovely voice. But it's uploaded to the cloud, so we'll make sure that's shared as well.
Exactly. All right. Thanks, everybody. Shashank, thank you very much.
Thanks a
Sam
lot.
and IO
Appreciate it.
Associates, thanks for
Thank you.
setting this
Thanks
up.
for the
And,
opportunity. Thanks, everyone.
right, everyone be safe walking back to your bedrooms tonight.
Have great evenings, guys.
Bye-bye.
All right.
Thank you very
See
much.
you
Have a
guys.
great evening.
Thank you.
Bye.
Good evening.
Bye.